Hey guys, what's up everyone? How are you people doing? Hoping that all of you guys are doing good and taking very good care of yourself. Welcome back to today's session. This is going to be session number 4 of machines, one of the most interesting and the coolest chapter that we have in ICSE 10th physics. That's what we're going to talk about. This is going to be session number 4. That means that we've already done 3 sessions before this, and if you haven't watched the videos of that already, please do that so that you're able to understand what we're going to do today. Alright, so before we get started, let me introduce myself. My name is Anoop. I'm a Master Teacher of Science here at Vedantu. A very warm welcome to all the new students and the old ones out there. Hoping that once again you guys are taking very good care of yourself. So yes people, today we're going to be talking about the block and tackle system. Yes, that's what we're going to talk about in today's session. We have already done about the combinations of pulley, one movable, one fixed and several other movable pulleys. We did about one fixed and one movable. We also did about mobile pulleys and single fixed pulleys as well. So we did a lot of the topics before that. Today we'll be talking about block and tackle system in particular. But as always guys, we'll start off with a very interesting quote. And the quote is this: spend time with the people out, spend time with the people who bring out the best in you, not the ones who stress, bring in stress to you. The thing is this guys, this is what I believe in, that your life is combination of 5 people that you spend your life with. This is what I totally believe in. So whatever your friend circle was, how much of a time you've spent with the people around you, your life shaped up to be like that. So it's true for my case, and it's true for your, pretty much everyone's. For example, I'll just give you an example that back in school time, back when I was studying, all my friends were into football. So I eventually got into that. Even I also started playing football. Many of my friends started going to tuitions. Even I started going to tuitions. So it's basically, we are influenced. What I'm trying to say is that we are influenced by the people around us. So it's always good to have people who's going to help you to push forward than to bring you back, because eventually then you'll stop believing in your own abilities and start believing what they have said or what you believe is true, which actually is not. So yes guys, that's what I say. With that said, let us get started with today's session. So people, in the past sessions we have done all these topics, from mechanical advantage to understanding about velocity ratios and efficiencies, so of single fixed pulleys to single movable pulleys to combinations of pulleys, one fixed and one movable, and one fixed and other movable pulleys also we have done. Today we'll be talking about the block and tackle system. So yes guys, let us get started without wasting any more time. But before that, in the last session I had given you a homework. Here was the question: what is the mechanical advantage of a combination of 3 movable pulleys with a fixed pulley? And the answer to this question, guys, you know the answer for this one. Mechanical advantage of single fixed and other movable pulley is basically 2 to the power n, where n is the number of movable pulleys. So in this case there are 3 movable pulleys, so it's 2 to the power 3, which would give you 8. As simple as that. If you want to find out the velocity ratio, that will also be the same exact thing. It will be 2 to the power n, which would give you 8. As simple as that. So that's it guys. Let us now understand about the block and tackle pulley system. So let's understand that. We have already understood about one fixed pulley and other movable pulley. We found out the mechanical advantage. So if you guys remember it, we saw that the mechanical advantage is equal to 2 to the power n. And if you talk about the velocity ratio, that is also equal to 2 to the power n. And efficiency of the machine, because efficiency is mechanical advantage divided by velocity ratio, that will give you 1, which is nothing but 100%. So these are the things that we've seen in the last session. In today's session, we'll understand how do we find out the mechanical advantage, the velocity ratio, as well as the efficiency of a block and tackle system. So yes, let us look at what a block and tackle system looks like. This is what a simple block and tackle system actually looks like, guys. First of all, how did the name block and tackle come into existence? Let me tell you that. So block and tackle system has been it has been used for a very long time. It's not a rather new invention. It has been there for a very long time. So the block, when you say block, those are, when you say block, it is referred to the pulleys. So the number of pulleys that are there, that is the block. Tackle is nothing but the rope. So the rope is called as a tackle. Block is the number of pulleys. So whatever is how many number of pulleys that you have, that is the block, and the rope is actually called as the tackle. Now in this case guys, if you remember, when we talked about single movable and other single fixed and other movable pulleys, we had seen that we had used different ropes. right? We had used different ropes because each of those mobile pulleys were, one of the ropes was actually fixed to a rigid surface and the rest was actually fixed to the load. That is how it went. But here the major difference is that, guys, you have only one rope. There's only one set of rope or one rope which connects the entire load and the pulley. Everything together is connected by that one single rope, and your effort is also put at the end of that one rope itself. So the diagram of this is something that you have to understand, guys. There's a little like there is a little difference when you think about it, that if you talk about if the the number of pulley, basically if the if the number of pulleys are odd number, then the end of one of the end of the rope or the end of the particular string will be connected to the mobile pulley. If in case the number of pulleys are even number, then the end of the pulleys would actually be connected to the fixed end. Now that is something where I'll tell you that in detail as we go ahead. But before that, guys, one more important thing I want to tell you is this, that in a block and tackle system, the number of mobile pulley can never exceed the number of fixed pulleys. So if in case, let's say the number of pulleys are 5, if the number of pulleys, if the total number of pulleys are 5, in that 3 will be fixed pulley, 2 will be your mobile pulleys. You can never exceed the number of mobile pulley. The reason is because if you were to exceed the number of mobile pulleys, the efficiency of the system actually reduces. Because, see guys, think about it. If you look at this block and tackle system, the entire load is basically balanced by these two pulley, which is fixed to that rigid surface. So all of that force is basically acting on this point itself, on that particular wall, because that is the one carrying the entire load. Now, because these two are fixed, the weight of that is you can ignore it because it is attached to the wall, so the weight of it would not act much. But the weight of the load and the weight of the pulley matters. Obviously they are not weightless, they'll obviously have some weight. So if you increase the number of mobile pulleys than the number of fixed pulleys, then the weight of the system would increase. That is the weight of the load including the mobile pulleys, which would mean that the efficiency of the system would drastically reduce. So when you're talking about block and tackle system, the number of mobile pulleys can be equal to the fixed pulleys but never greater. It can be equal to or less than the number of fixed pulleys, but never greater than that. That is the first thing that you have to remember. That's a very important point, guys. Don't ever ignore that. It's the first most important thing that you have to understand. Apart from that, like I told you, here you have one single rope which connects the entire the entire block system. So the entire blocks or all the pulleys are connected by that one single rope passing through it. All right, so that's it, guys. Now let's look at how it really functions. So this is how a block and tackle system works, guys. So the load is actually kept on the mobile pulley. And first of all, to tell you what are mobile pulleys, if you remember in the first session I told you that the fixed pulleys are the ones where the axis of rotation is fixed. So you see that it's rotating about a particular point. Like you can take the example of a fan, it rotates about a particular axis. And on the other hand, if you talk about a mobile pulley, the axis is also moving along with it. So as the the rope as you put the effort, the pulley is also moving up and down. So the axis of rotation is not fixed. That is why it's called as a mobile pulley. So that is the first thing that you have to remember. So here it is, the number of lower pulleys can be equal to or less than 1. Like in the case of this one, it can have you can have up to 2 mobile pulleys if you want to, depending on what load or how much load you're carrying. So that is one thing that really matters. Now people, let's look into this. What is the advantage that I'm going to get if in case I were to use a block and tackle system? Let's start with the first one. All right, I'm going to take this as the first one. Let me just take this one because we've already done this before, right? We have seen a single fixed and mobile pulley. We have seen that before. Now, in this case, first of all, what is the mechanical advantage in a single fixed and a single mobile pulley? In a combination of that pulley, we have seen that we saw that the mechanical advantage is equal to 2, and the velocity ratio we also found it as 2. Velocity ratio was also 2, mechanical advantage was 2, efficiency was 100%. How do we come to that conclusion? Now again, guys, you already have seen that. I've already put it up in the in the past. I've told you this already, so I want you guys to go through the videos and understand that. So we have seen that the mechanical advantage of one single and one mobile pulley would be 2. Velocity ratio is also 2. So that means that what is mechanical advantage? Mechanical advantage, let me just write that over here. So what is mechanical advantage? Mechanical advantage is equal to load by effort. So if I have to calculate the effort in this case I told you that the mechanical advantage is 2. So it'll be what? 2 is equal to L by E. So if I want to calculate how much effort I have to put for a certain load, so E is equal to what? L by 2. L by 2. So what is happening? So imagine that the load is 100 Newton. The effort would be reduced to 50 Newton. So it acts like a force multiplier, reducing your effort. That's what it does. So basically your mechanical advantage actually is 2, because that is why it is called as a force multiplier, and thus your effort needed to lift up that same 100 Newton force, or that weight, is actually reduced to just 50 Newton. If in case, let's say that I add on to those number of fixed as well as movable pulley, let's see what happens in this case. So I'm lifting up the same exact object, the mass is 10 kg and the weight is calculated as 100 Newton. Now in this case, guys, if you guys remember it, I told you that the mechanical advantage in these kind of, if you talk about a combination of pulley, we saw that it's 2 to the power n. Now, I told you one thing, that in a, when you have a movable pulley, whatever you lift or whatever is the load gets equally distributed to both the ropes. We had seen that. So when we when we talked about in the previous session, when we talked about the movable pulley system, we saw that whatever is the load gets equally distributed to both the wires or both the cables which had tension T. Now here the exact same thing is happening, but then if you look at it, guys, to carry this one single load of 100 Newton, how many wires are the ones that is responsible for carrying it? There are 1, 2, 3 and 4 wires, or 4 ropes, or 4 cables lifting up that same 100 Newton force, which means that whatever is that 100 Newton force gets equally divided 4 times, which is 100 divided by 4, which means that the tension on each and every wire is nothing but 25 Newton. Now, the last pulley, the one that is fixed over here, is a single fixed pulley, and in a single fixed pulley, the effort is equal to load, because the mechanical advantage is equal to 1. So whatever is the tension on this cable, the last cable, the effort would also be the same. So over here, what you have to look at is this: from 50 Newton, your force or your effort has been reduced to half, to 25 Newton, just by adding another 2 more pulleys. And that is the advantage of this, guys. That is the whole point of this. You're trying to reduce the effort from your side as much as possible. And that's what you're doing over here by the more number of pulleys you add, the more number of the ropes would be the one that will be, the load will be divided into so many different number of ropes, and thus your effort would also drastically reduce. So yes, guys, that is what is happening over here. Your force is actually reduced to half of it, to 25 Newton. Alright, now if you look at the distance moved also, you see this, the distance moved by the load is 10 centimeter in both the cases, but then the distance moved by the effort in the first case is 20 centimeters, whereas in the second is about 40 centimeters. I'll tell you how that came into existence when we calculate the velocity ratio. I'll tell you about that in a minute, but before that, guys, this is how it's going to be. Now, the thing is, people, if I have to compare all of these with a single fixed pulley to a combination of single fixed and single movable, and a block and tackle system with three pulleys in total, and a block and tackle system with 4 pulleys, you can clearly see that your effort is reducing by adding the number of pulleys. For the first one, like when you talk about a single fixed pulley, we have seen that it's actually just for the convenience of direction. It has got nothing to do with the force multiplication, because whatever effort you put, that is the same effort that is needed to lift up the load. So for example, if you have to lift up a load of 100 Newton, you have to apply 100 Newton force to lift it up to that certain height, because yes, the load is equal to effort, because the mechanical advantage over here is basically 1. The mechanical advantage is basically equal to 1. So 1 is to 1. So whatever is the effort, that will be equal to the load as well. If in case I have one movable and one fixed pulley, over here you see that again the tension, whatever is the load, that gets divided into 2, because the ropes, the tension on the ropes, so it'll be 2, so it'll be 50 Newton over here, 50 Newton over here. In the opposite direction, that is T, so T will be equal to 50 in both the cases. So in this case, the effort would be reduced to 50. And now, guys, what you must be wondering, sir, what is this 200 Newton, 150 Newton, 133 half Newton? I'll tell you that in a minute. First of all, guys, let's look at what are the different changes that you see. In the third one, when you have three fixed or three mobile pulleys, or three pulleys in total, where one is mobile and two is fixed, you can see that the effort now gets divided into three different ropes. The three different tension on the rope is the one that is carrying up or lifting up the load. So over here it will be 100 divided by 3, which will give me 33.333 Newton, which is nothing but 33 1 by 2, 1 by 3 Newton, I believe. Yes, 1 by 3. Yes, 1 by 3 Newton. So that is what you're going to get over there. If we talk about the fourth situation, where you have 4 pulleys in total, where 2 mobile and 2 are fixed, over here it'll be divided. We have just seen that it'll be divided into 4, so that'll give me 25 Newton. Now, if you look at this, guys, you see this, your effort and your load in each of these cases, your effort is reducing every single time you increase the number of pulleys. From 1:1, it is going to 1:2. That is, the effort is still 100, but sorry, the load is still 100, but the effort is reduced to half of it. If we talk about the third one, the effort is reduced to 1/3 of it. If we talk about the fourth one, the effort is reduced to 1/4 of that of the load. So the more number of pulleys that you have, the lesser would be your effort. As simple as that. Now to talk about what exactly this 200 Newton, 150 Newton, 133 by 1 by 3 Newton and 125 Newton. So here's the thing, guys. Obviously there is some force acting over here on the rigid wall. There is some force. And that force is what is basically, that force is the opposite direction, because you're pulling it down. The weight of the load, the weight of the pulleys and everything is pulling it down. So there should be an opposite force so as to balance it. No, according to Newton's law of motion, according to Newton's third law, what is it? According to Newton's first law, for every action there's an equal and opposite reaction. So this is called the reaction force. So here the load is 100 Newton, the effort is also 100. You're also pulling it. You're also pulling it with the force of 100 Newton. The weight is already 100 Newton. So it gets added up and the reaction force would be 200 Newton. For the second one, your effort is reduced. So it'll be 50 Newton. You're pulling it with a force of 50 Newton. The effort is still 100 Newton. So you add it up, you get it as 150 Newton. For the third one, it will be 133.33 Newton. For the fourth one, it'll be 125 Newton. So if you look at it, the force on the rigid wall is also reducing by increasing the number of pulleys that you have in a block and tackle system. Now guys, now that you've understood this, let us now calculate what will be the mechanical advantage, what will be the velocity ratio and the efficiency in a block and tackle system. So let's take an example. Let's say there's a simple block and tackle system. You have 5 pulleys in total, 3 are fixed, 2 are mobile. Like I told you, the mobile pulleys should never exceed more than the fixed pulleys. So you're maintaining that, you're abiding by the rules. 3 fixed and 2 mobile. Now again, you see this is the cable. It starts all the way from here. So let me just draw it out. So it goes from here all the way to the down one, then to the second one, then to the second one over here, and then comes back and then fixes over here. So yes guys, if you think about it, there are 5 cables which is lifting up the same load right now. So this is cable number 1 with the tension T. This will also be tension T. This is another cable, this is another cable, and this is another cable. So there are 5 cables right now lifting up that same exact load with again, so whatever is the load, it'll be divided by 1/5 over here. So the tension on each and every cable would be L/5, because on each of these, again, the load gets equally divided to all the 5 ones, and obviously the effort would also be the tension on this particular cable itself. Alright guys, so let's calculate the mechanical advantage right now. Let's do that. So start with the load. So here the load is given as so load would be what? It'll be 5T, because obviously it is divided into 5 different all the 5 ropes. So it'll be 5T, and the effort is T, because obviously whatever is the effort, that will be T itself, the tension on the rope itself, so that will be T. So if you calculate it, what is mechanical advantage? Mechanical advantage is equal to load by effort. Load is 5T divided by T. T gets cancelled and you'll get us 5. Now people, if you just think about the number 5, it has got something to do with it. Because if you calculate it, there are 5 pulleys in the system, and the mechanical advantage also you found as 5. So do you think that there is some relationship between the number of pulleys and maybe the mechanical advantage? Absolutely yes. See guys, in a block and pulley system, the mechanical advantage will be equal to the number of pulleys. So if you have 7 pulleys, the mechanical advantage would be 7. So mechanical advantage, you can directly write it as N, where N stands for the number of pulleys. It is not whether it's fixed or mobile, everything together, whatever is the number of pulleys, that will give you the mechanical advantage. Now to calculate the velocity ratio. See guys, velocity ratio is what? Distance moved by the effort divided by the distance moved by the load. The velocity ratio also, if you just calculate it, you will get it as 5 itself, because over here, whatever is the distance, let's say the distance moved by the load is d, then the effort has to move 5 times that particular distance. If you just go back to that example, let's just go back to that particular example. You see this over here, the distance moved by the effort. Okay, let's take this one. So the distance moved by the load is 10 centimeters. The load has to move, or the effort, the distance moved by the effort is 40 centimeters. And how many pulleys are there? There are 4. So basically it'll be 4 times the distance moved by the particular load. So here also, because there are 5 pulleys, over here it'll be 5 into the distance moved by the load. So if you calculate it guys, what is the distance moved by the effort? That is 5d. Distance moved by the load is d. dd gets cancelled, you'll get it as 5 again. Again, coming to the conclusion that velocity ratio would also be equal to the number of pulleys that you have in that block and tackle system. So VR also will be equal to N. Efficiency, what will be the efficiency? Mechanical advantage divided by the velocity ratio. Both of them are same, N gets cancelled, you'll get as 1, as simple as that, which means that efficiency would also be 100%. If, again, assuming that there's no friction, assuming that the rope is weightless, assuming all of that, assuming assuming that the weight of the the movable pulley is also negligible, assuming all of that, we can say that the efficiency is 100%. But people, towards the end, I mentioned this one statement that we are assuming that the weight of the pulley is negligible. What if I were to consider the weight of the pulley as well? Obviously, there's the weight. I know in the real life, obviously the pulley has some weight, but we are assuming, for our own convenience, we're saying that the weight is completely negligible. That's why we don't calculate it all. What if I were to consider the weight of the pulley as well? How would this affect my mechanical advantage, my velocity ratio, as well as my efficiency? Let's start with understanding about the load itself. Now guys, in a balanced position, that is when the pulley is not, when the load is not moving up or down, in a balanced state, whatever is the tension of the cable, the effort would also be the same, to make sure that it is in equilibrium. So you have to put in whatever is the tension of the wire, you have to apply equal effort to make sure it's not moving up or moving down. Effort is the same, but load would be the load itself plus the weight of the particular pulley. So it'll be L plus W, which is equal to NT. What is N? The number of pulleys that you have. Now, here guys, if you were to calculate the mechanical advantage, let's just try to calculate it. So mechanical advantage is load by effort. So load is what it is. So if you have to calculate N, what is L? L is equal to what? It'll be NT minus W. NT minus W. I'll take W to the other side, it will be NT minus W. So what will I get over here? So NT minus W divided by T. Very simple. Now, what I'm going to do is that in place, okay, I'll just keep it as not T, I'll take it as E. Alright, divided by E. Now, in place of T, I'll substitute E because, again, the tension on the cable and the effort is the same. So what will I get? NE by minus W by E. Now what I'm going to do, I'll just separate the equation, I'll just separate it and simplify it. So I'll be NE divided by E minus W by E. E gets cancelled. What are you left with? N minus W divided by E. Now guys, this will be the mechanical advantage if I were to consider the weight of the pulley as well. Now imagine this, imagine the weight of the pulley is 0. So what will you get? N minus 0 divided by E, which again is 0. So ultimately the equation does not change. This is the actual equation. Because we don't consider the weight of the pulley at all, we'll just write directly mechanical advantage is equal to N. But the fact of the matter is this is the actual equation. Again, we are considering, when we consider the weight, the equation changes to N minus W divided by T, where W is the weight of the the block, or what is that, the pulley, and E is nothing but the effort itself. As simple as that. Alright, moving on to understanding about the velocity ratio. The thing about velocity ratio, guys, the velocity ratio over here would not change if you were to consider the weight as well. The velocity ratio would not change, because whatever is the distance moved by the effort would again be the same as that of the the number of pulleys that you have. So velocity ratio would not change at all, so it will remain as N, whereas the mechanical advantage would differ because you are also considering the weight of the the pulley as well. Alright, so yes guys, the mechanical advantage would be N minus W by E, whereas the velocity ratio would be actually equal to the number of pulley itself. It does not matter at all. Now, because it is the case, the efficiency of the system would also reduce if in case we were to consider the weight of the of the pulley as well, because obviously it's N minus the weight of the pulley divided by the effort. So obviously it's going to be negative. So I mean, you're subtracting it. So obviously the efficiency would not be 100%. It'll be reduced. So to make sure you get maximum efficiency, you have to reduce the number of pulleys that you have, because the lesser the weight, the more the efficiency would be. So you have to reduce the number of pulleys, because obviously the more number of pulleys means the more will be the weight as well. Alright, so with that said, people, before I get into the quiz right now, a very important, rather interesting thing to tell you. Now, I'm pretty sure that all of you guys face a lot of problems, especially at this point of time. You're when you're away from your school, where you don't have friends to ask your doubts, and then no teachers to directly ask or interact with them. You'll be facing a lot of problems. One is probably doubt solving. Yeah, that is one thing that you definitely find hard. The other could be that you're not getting the right notes. The other might be that you're not able to choose your own schedule. So you have a lot of problems that you can think of. Just think about it. You'll have a lot of problems like this that you're facing every single day, and maybe you're not able to find the right solution for all of these problems also. But yes guys, Vedantu's here to solve all your problems in one single shot. So what you have to do is this: just go to vdnt all small .in/ytpro. If you go to this website, you will first get this one single box where you have to choose your grade. So whichever grade you're in, 1 to 12th grade. So basically Vedantu is catering from 1st standard to 12th standard. All the students, everything is covered. Let's say that you're in 10th standard. Let's say that you're in 10th standard. So you will get all of these notifications like unlimited access to live classes. So obviously how many ever classes you want to attend in a day, you can go for it. You want to attend 5 classes, go ahead, do it. If you want to do 15 classes in a day, that's if you want to attend 24 classes. Or without sleep, you want to continue, reading at Vedantu, that is also possible. You will also have the interaction with the best teachers in the world. I totally believe that the teachers at Vedantu are exceptionally good. You'll have unlimited in-class doubt solving. So you'll have a class teacher as well as the master teacher. So the master teacher, apart from teaching, would also help you clear your doubts. Together with that, you'll also have a class teacher along with you guys, where you get personalized attention to make sure that your doubts are solved inside the class right there and then. You'll also have unlimited test series where you can test yourself and check where you're going wrong and what are the things that you have to do to improve yourself. And you'll also have the schedule of your choice. So whenever you feel like studying, you can choose that schedule and study. And all of this means obviously your score would also definitely improve. So here's the thing guys, what you have to do is just click on get subscription. Once you click on that, you will get this dialog box where it says 1 month, 3 months and 6 months. So it will be like 2,699 rupees per month, or 2,333 rupees per month, or 1,912 rupees per month. Now here's the thing guys, first of all, before the coupon code, let's say that you want to choose 1 month subscription, what happens is that the course price will be 2,699 rupees. If you just before you apply the coupon itself, this is what you're gonna get. If you apply the coupon code AKPRO, you would get additional 400 rupees. I'm just talking about the first month. You'll get an additional 400 rupees discount, and you'll get the price down to 2,294 rupees. All right, that is for 1 month. So if you, let's say that you choose for 6 months, the discount that you get, the discount amount would also be greater or be larger. So if you just think about it, guys, for 1 month you're only paying 2,600 change, but for 3 months you're reducing that cost to 300 rupees lesser, to 2,300. For 6 months it is reduced down to about roughly about 700 rupees to 1,900 rupees. So the more number of days you take, the lesser would be the price on that particular month. So here's the thing, guys. This is the cost. Let's say for 3 months, if you want to check it. So 3 months, the cost is 6,999 rupees. That is before coupon. So if you add this coupon, you'll get if you add the coupon code, that is AK Pro, you'll get it down to, you'll get a coupon, you'll get a price drop of 1,049 rupees, bringing the price down to 5,949 rupees. So obviously you're getting a larger amount. For 6 months, again, 11,499 rupees is the course price before the coupon. After the coupon, it'll come down to 9,774 rupees. Now I'll tell you why I'm telling you all these numbers. So here's the thing, guys. Before subscription, before the coupon, this is what you're gonna get. Let's do some math. Let's take a minute and let's do a math. Now, after the coupon, after you apply the coupon code, that is your primary discount, that is AK Pro, you'll get 2,900 rupees. Over here, you'll get it as 6,990 rupees. That is the actual price. This is the price before, that you're going to pay. That is a primary discount. Even without adding any kind of coupon code, you're already getting a discount of 6,999 rupees and 11,502 rupees. If you apply the coupon code AK Pro, you will get it down even more further to 2,299 rupees, 5,949 rupees, and 9,779 rupees. So you're getting a lot of discount over there. Now, here's the thing, guys. So yes, guys, let's say that you're attending about 8 classes per day, 6 subjects. You're all science subject with social science, English, mathematics, everything together. You are attending about 8 classes per day. So just again, it's totally up to you. You can have to 10, even 20 classes. It's totally up to you. But let's say that you are attending about 8 classes per day. Now, in a week, you would have attended about 50 classes, right? 7 days a week. Let's say that Sunday is a holiday, so let's say 6 days a week. So you're attending about 48 classes for our math, because I like simpler calculations. So let's say that you're attending 50 classes a day in a week. In 4 weeks, you would have attended about 200 classes roughly. About 4 weeks, 50 into 4, 200 classes. Now, if you just think about it, guys, let's say for 1 month subscription, let's say you paid 2,294 rupees and you're attending 200 classes per day. Or let's say that you took the 3 month subscription, which is about 5,949 rupees divided by 600, and 9,779 rupees for the 6 months course divided by 1,200. That is the number of again, for 6 months. Again, for 1 month you're attending 200 classes. For 6 months it'll be 1,200 classes, right? Now, if you just calculate it, guys, 2,299 rupees divided by 200, you'll get the price to 11.47 rupees. All right, 11 rupees 47 paise. All right, 11 rupees 47 paise. For 3 months, you're essentially paying for each class. You're paying 19 rupees 19 paise. For 6 months, if you take up the 6 month subscription course, each class you're paying just 8 rupees 145 paise. Now, guys, that is just less than what you spend every day for the things that you eat. For Lays, let's say, Lays packet costs 20 rupees. You're able to get enough knowledge from the best of the best teachers in the country for less than 11 rupees. Think about it, guys. So all you have to do is basically this. Visit this website, vdnt.in/YTPro. Use the coupon code. Don't forget to use the coupon code AKPro. That's all, and you will get the price. Like I just did the math. You guys know what to do. Rest. Do that and let me know what you think about it. All right. So anyways, guys, with that said, let's now solve some questions and try to enlighten our brains a little bit more. So here's the first question. A block and tackle system has 5 pulleys. If an effort of 1,000 Newton is needed in the downward direction to raise a load of 4,500 Newton, calculate the velocity ratio. Suppose you calculate the velocity ratio. They have given you what is the force. They've given you the effort. They've given you the load as well. You're supposed to calculate the velocity ratio. And there are 5 pulleys in this block and tackle system. What would be the answer, guys? I can tell you, even without calculation, the answer would be option number A, that is 5. Because velocity ratio in a block and tackle pulley system is nothing but n, where n is the number of pulleys. So directly you can say that it is 5, guys. You don't even have to calculate it. Direct answer, 2 mark Done. That's all. Next question. Figure shows a block and tackle system pulley used to lift a load. How many strands of tackle are supporting the load? How many strands of tackle are supporting this particular load? That is the question. Now remember guys, I told you that tackle is nothing but the rope. Tackle is nothing but the rope and block is nothing but the pulley. So how many ropes, to make it more simpler, is supporting that particular load in this case, which is basically mentioned as W? What would be the answer? Would it be 6, 3, 2 or 4? The answer guys would actually be 4. Why 4? Because if you calculate it, this is 1, this is 2, this is 3 and this is 4. There are 4 ropes, or 4, the same rope basically is the one that is the same. If you think about it, it's the one rope itself. I'm not saying 4 different ropes. It is a single rope, but all of that because of the fact that they are moving, up and down throughout the pulley, you are able to say that the load is actually distributed equally among those 4 ropes, which is again 1, 2, 3 and 4. Because again, you can again come to the conclusion that again the number of pulleys that you have, that will be the number of ropes that will be supporting, or the number of tackles that will be supporting that particular load as well. So if you have 5 pulleys, then the number of tackles that will be supporting the load would be 5, as simple as that. So the number of ropes or the number of tackles would also be equal to the number of pulleys, as simple as that. Alright, so that is the answer guys. The answer to this question is nothing but 4. Simple as that. Moving on to the next question. Here we go. In a block and tackle system consisting of 3 pulleys, a load of 75 kgf is raised with an effort of 25 kgs. Find the efficiency. Suppose I find out what is the efficiency. The block and tackle system consisting of 3 pulleys, a load of 75 kgs raised with an effort of 25 kgs. Find the efficiency. Is it 100%, 10%, 75% or 80%? The answer guys, what is the answer? I would directly say that the answer is option number A, that is 100%. But let's do some calculation. Obviously, we can't just write that in your exams, no? So there are 3 pulleys over here. So if you remember, what is efficiency? Efficiency is nothing but mechanical advantage divided by velocity ratio, right? What is the mechanical advantage in this? There are 3 pulleys. As a block and tackle system, it's nothing but N, which is nothing but 3. And velocity ratio is what? Is nothing but N again, the number of pulleys. So it'll be 3 again. So what is new? It's nothing but, which is what is the efficiency? It'll be 3 divided by 3, which is nothing but 1. Simple as that. That's all guys. So 1 is what? That means it's 100% efficiency. As simple as that. Again, without even calculating, you can directly tell the answer. But still, you have to show the calculation, because obviously your teachers are going to think that you copied the answer if you just write the answer. So you have to calculate it as well. Alright. Moving on to the 4th question. Here we go. A block and tackle system has a velocity ratio 3. A man can exert a force, a pull of 200 kgf. What is the maximum load he can raise with the pulley system if the efficiency is 60%? Is it 150 kgf, 300 kgf, 360 kgf or 200 kgf? So they've given you the velocity ratio, they've given you the force exerted, or basically the effort they have told you. They have also given you they've given you the efficiency as well. You're supposed to find out what is the maximum load that particular person can lift using that particular pulley system. So let's write down the given data first. Velocity ratio is given as 3, and the effort is given as 200 kgf. I'm not going to change it to Newton, because answer is also given in kgf itself, so I don't have to change it to Newton. If I have to change it, then multiply by 9, multiply with 9.8. All right. So efficiency is given. Efficiency is 60%, which is nothing but 60 divided by 100. That is 0.6. Right. So first of all, calculate the mechanical advantage. How would you calculate the mechanical advantage? Efficiency is equal to velocity, mechanical advantage divided by velocity ratio. So what is mechanical advantage? This would be equal to what? VR into efficiency. Very simple. Velocity ratio is how much? 3. Efficiency is 0.6. Multiply it, you will get the answer as 1.8. 1.8 is the mechanical advantage. Now that you found out the mechanical advantage, find out the load, because mechanical advantage is what? Load by effort. Effort is already given. Mechanical advantage you got is 1.8. Load, effort is how much? 200 kgf. So load will be equal to what? 1.8 into 200. If you multiply it, you will get it as 360 kgf. As simple as that. That's all, guys. Very simple question. Might seem a little, confusing, but then it's actually a very straightforward question. You just have to do a little thinking and you're good to go. Alright, guys. So that is it from my side. That is the last question. But yes, never forget your homework. Here's the question, guys. The mechanical advantage of a block and tackle system consisting of 3 pulleys with a load of 3,800 Newton and the effort is 1,200 Newton is how much? What is the mechanical advantage? It's a 3 pulley system. The load is 3,800 Newton and the effort is 1,200 Newton. Find out the mechanical advantage. Go for it, guys. Let me know what is the answer in the comment section below. And the faster you answer, your name would be there in the next session. Alright, guys. So all the best for that. Now, with that said, people, thank you for joining today's session. I hope you guys enjoyed it. I hope you guys learned something new today. If you guys did enjoy today's session, give a like and subscribe to the channel so you're aware of whatever, you have all the other subjects as well. You have English and mathematics and, chemistry and biology. All of that is going on parallelly. So just be notified and be a part of the Vedantu family. Thank you for joining today's session, guys. If you want to reach out to me personally, you have a doubt, put it down in the comment section below. If you want to reach out to me personally, you can also reach out to me at anoop.manoharan@vedantu.com. Alright. Thank you for joining, guys. See you all in the next one. Take care of yourself. I'll catch you guys in the next one. Bye bye, people. Take care.